Hi all, welcome to part 23 module 2 logic system design. So we were discussing about K-map, and in this video we are going to see particularly about something called a 5 variable K-map. Okay, so so far you are very much comfortable with the 4 variable K-map, and many problems we saw already. And this is something I already told you, as it is mentioned in the syllabus. I am explaining you most of the questions if you see in the previous year and all, you can expect questions for up to 4 variable, but in the worst case if they are asking you some problem from the 5 variable, you are now able to solve it. Okay, we will see that. So this is a typical structure. We are just extending what we seen already. This is one way of extension, but there are other ways also. In Morris Mann or textbook, the PDF I am having, when I refer, this is not given. So I referred some YouTube video, and from that I taken the screenshot and it is here. Yeah. So let's see. So the concept is like 5 variables are there, right? So A, B, C, D, E. That is how my function looks like, and I hope these things are clear to you already. 5 variable expression means what? Say when I have 5 variables with me, A, B, C, D, say E also, I have a function of this A, B, C, D, E. So how many assignments I will be getting? 0, 0, 0, 0, 0, 0, 0, 0, 1, like that. So half of the assignments, the most significant bit will be 0, and this part will go up to this. Then second half, this A will turn to 1, and these bits will reset to 0. Then again 0, 0, 1, etc. The last combination will be 1, 1, 1, 1. So you know this is our 0 in decimal, this is 1, and this is your 15, the first half, right? And this is your 16, this is your 17, etc. Finally this is your 31. So using 5 variable, you can have a 2 power 5, that is 32 assignments combination. Yeah, and corresponding to each of them, this will be mapped to a particular value. So it can be something like, it can be mapped to 1, this can be mapped to 1, and this say I am going to map to 0, this I may be mapped to 1, randomly I am mapping, there is nothing else, something like this. So this is how a 5 variable boolean function looks like. Okay, so that about it. Now when the same truth table I am visualizing as a, so if I am writing like this, this is no longer a truth table, right? Okay, so truth table feel I want. So what I am going to do is, let me write the values like this. Let it be 0, let it be 1, let it be 0, 0. Randomly I am assigning some values for them, whatever it is. So that is the case. This truth table is what I am trying to visualize as a K-map. Yeah, this is a thing. So when you are visualizing it as a K-map, what we are familiar with the 4 variable K-map, right? So here out of this 5 variable, the least significant 4 variable you focus, that is B, C, D, E, and that for that B, C, D, E, you know how to draw the truth table. Okay, so just take 2 copies of it and let the first copy corresponds to an assignment of A, that is say 0. So when A is equal to 0, I will be referring to this part, this truth table. This is actually the K-map representing the first half of the truth table, something like that. And this is a K-map, part of the K-map that is representing the second half of the truth table. The first half of the truth table, you can see, one second. This template I taken for giving you an example. Let's see, experiment with this. So the first half of the truth table is having an assignment of A is equal to 0. You can see that the first half. So this corresponds to A is equal to 0. And what about the B, C, D, E? They are going from 0 to 15. And here also this corresponds to A is equal to 1, and B, C, D again is going from 0 to 15. So same thing you can use, reuse, 2 duplicates you can use like B, C, D, E. So here also I have a K-map equivalent to the second half. Hope it is clear, right? Now the marking, everything is just like before. So again I am going with this. This is where I have to take an example. Sorry for that. I was saying about this. So B, C, D, E. And the min terms are marked here, and you know the normal marking 0, 1, 2, 3, that numbering you know. Now in the first half there is no confusion, just look like the previous one. It will start from M0, it will end with M15. Now for the second one, you know, instead of 0 you have to start with the 16, and the same filling you have to use 16, then 17, 18, 19, 20, 21, 22, 23, then go last 24, 25, 26, 27, and it will also end at the same position, just like M15. Here I will be getting M31. And you know why I am numbering like this? Because this corresponds to the second half. A is equal to 1. So instead of 0, equivalently when A is equal to 1, it corresponds to 1 followed by 40, that is 16, just like that. So, okay, now this min-term marking, everything is clear, I hope so. Now finally let's see an example, like this is what I am having. So let me mark the min-term into the KMF first. So 0 is there, fine. Then 2 is there. Where is 2? 2 means 0, 0, 1, 0. This is 2. Or you mark the min-term and you map it. It will be easy. Then 4 is there. That is 0, 1, 0, 0. 4 is there. Then 6 is there. 0, 1, 1, 0. 6 is there. 4, 5, 6, 7. Like that it is coming, right? Then 8, 9. So this is my 9, right? 1, 0, 0, 1. 9 is there. Now what else? Then 13 is coming. 9, 10, 11, 13, 14. Something like that. Is it correct? Which is 13? See, 8, 9, 10, 11, 12, 13. So this is 13. 14 and 15. Or you look at the binary of 13. 1, 1. 1, 1, 0, 0 is 12, right? 1, 1, 0, 1. Yeah. This is your 13. So 13 till 13 and marked, and then I want 21. So here either you can take the binary of 21 and you can mark it, or you it's always better for you to go like this. So from here it is very easy. M21 is this cell. So come to this, put a 1 here. Then where that M23 resides, immediately next to that. Then M24 is somewhere here. Sorry, 24, then 25. 25 is there. Right, M25, then 29 and 31. Where is 29? 29 is here and 31 is here. This is 29, this is 31, I think. 29, 31, yeah, that about it. So this is how I have to mark. Only thing I have to know the numbering, or you know, just mark the min-term just like the fixed procedure we are having, and accordingly do this one mapping, whatever it is, or take the binary and map it. That's all. Now how to group them? So now you can visualize it like say what I can say. 1 second. Let's continue. So now you can group them. So the normal grouping procedure, it's only we are considering, but some more cases will be coming. So it is just like you can visualize this one of the 4 variable K map is resting over the other one, something like that. So A is equal to 0, let it be at the bottom, and above that one this A is equal to 1 is residing. So just visualize that way. In that way can you group any 4 ones, something like that. So here something like that is happening. So if you focus on this grouping, this is very important. This one and this one together is a single group. I am saying like that. So this one and this one together is a single group. Why it is a single group? Because these two together will form one grouping. And what is the term corresponding that? So these 4 ones are adjacent to each other when you place one of the 4 variable K map over the other one. Right, that you can visualize, right? These 4 ones are coming adjacent. So that is a way. So that possibility also you have to consider. That is the only difference. So if that is the case, tell me. So now you can see that I have a shift from this 4 variable K map to this one. That means this A variable is actually changing from 0 to 1, or A variable is eliminated or cancelled. So when you are writing this, if the group is something across 2 different 4 variable map, that particular most significant variable will be eliminated. You got the idea, right? Because it is changing from 0 to 1. Now what remains? So if you are looking at here, you can see that. So when you are going across this part, so how many ones are grouped? That is my first question. So here you can see that 4 element group. I have a 4 element group. So when I am having a 4 element group, it means what? 2 power 2. 2 variables are eliminated, right? 2 variables are eliminated means totally I have 5 variables. So the final expression is going to contain only 3 variables. Keep that in mind. So one variable eliminated is this A that you understood. Another variable which is eliminated is this C. You can see that the C is changing from 1 to 0. So that is eliminated. So what remains is this B remains as it is, and across the column that is fixed again, that is D dash and E. See the top, D dash and E. Okay. So this is the what? This is the term corresponding to this one. So it's very important. Keep that in mind. So the particular term is like B D dash E. So that is the first say prime implicant I am getting. Okay. Now what about the next one? So when I am grouping the next one, so here there is nothing. When I overlap to 4 variable K map, this is the only different thing I am getting. So here it is only across the first ones. The normal things all you can apply. Only thing you see something extra is possible or not when you place one 4 variable map over the other one. So this is a normal one. So this one you know how to write the term. So what is the term corresponding to this? You can see that when you so first of all it is in the first 4 variable K map corresponding to a equal to 0. So you can see that A dash, so that is there because A is assuming a value 0 here, or A dash is the corresponding literal, right? SOP I am writing. Now when I am moving across the row, I can see that the variable C is eliminated. Again 4 variable grouping, 2 variables will be eliminated, 4 element grouping, 2 variables eliminated, 3 variable remains. So keep that in mind. So C is eliminated. So what remains is B dash. Now when I am moving across from the first column to last column, 0 to 1, D eliminated, and E is again in the complemented form, something like E dash. So that about it. Now what else? The last grouping, it is something like this. These two 4 ones. That is again in the from the second 4 variable K map. There is no overlapping with the first one. And for this one, yeah, let me use this color. For this particular map, what is the equivalent term? You can see it corresponds to, say it is in the second 4 variable map. So A is equal to 1. So A will be there, right? Let me write here. A will be there. Then what else? When you move across a row, B eliminated and C will be there. Move across a column, D eliminated and E will be there. So ACE, it corresponds to ACE. So I am getting this as one of the min term, and another min term I am getting is this one, right? Now the first one is interesting actually, that is this. This is interesting because it is the only one that you find different, because this you have to visualize when you place one of the 4 variable K map over the other one. So the minimal expression SOP will be containing all the 4, because all of them are essential also, right? Some of the one is exclusively covered by the, yeah, definitely. So all together, so this one I am not writing here, right? What is a minimal expression? You add this prime implicant plus this prime implicant, and this prime implicant will give you the final minimal expression. Yeah, that about it. Hope this 5 variable concept is clear. So in worst case, if they are asking you, just understand the structure and map the ones, right? And after that group like what you done already. Only thing you consider these extra cases where one table is placed over the other one. Is it possible to have a bigger groupings? That you keep in mind. Yeah, that about it. Thanks for watching. So K-map topic as a whole we are winding up here. Any doubt you can comment in YouTube, wherever it is, Moodle, whatever it is, we will see the solution, okay, maybe in the live classes and all. So in the next topic onwards we are moving on to the circuit design. Yeah, thanks for watching.